Hello everybody. Today we're going to be talking about radians. Now, a radian angle is created by a rotation using the radius and passing through an arc length, which we call S. In order for this to make sense, I think I'm going to give you a visual. Pretend it's, summer, and here's a sprinkler. And the water shoots out of the sprinkler. And then it, kind of goes around your yard. Now the radius of the water doesn't change. So as far as the water shoots out, that's your radius. And the arc length, let's say, your driveway is here, so your parents don't want to water the driveway, so they set the sprinkler head to only go as far as this part here. So I'm just gonna do that. This would be S. This would be the length of the arc that the sprinkler head is making when it shoots out the water. Now this in here, this angle that it creates going from the beginning to the end, and then it goes back and then it goes forward, this would be the angle in radians. And you did this last year in geometry. Some of you might remember this and some of you might not. Today is a complete review day on radians, and I'm hoping that it comes back to you by the end of today, and I'm hoping that you enjoy this. I think it's kind of fun. So anyway, so the formula that we use to find any one of these three pieces, the R, the S, or the theta, the angle, I always call this formula S theta R, like yes they are. Believe it or not, people actually remember the formula when they see this picture. They go, oh, that's a yes they are picture. S equals theta R. So let's just say that you have a radius on your sprinkler head of 4 feet. Okay, so the radius is 4 feet. And you cover an arc length that, let's say, is 20 feet long. So if you were to actually measure this circular amount of wet grass, you get 20 feet. What's the angle? Now this angle is going to be in radians. It's not going to be in degrees. If you remember last year, radians are pieces of circles, and notice this is making a portion of a circle, and the arc length is part of the circle. So radians come from circles. And so if we wanted to find out the angle in radian form, we would say, okay, my 20 feet, and I don't know the angle, but I know the radius is 4 feet. If I divide by 4, my angle is 5 radians. Okay, so I got an angle of 5 radians. Might seem a little strange, but this is what we're going to be using right now. We could also give a different example. Let's say you are a pendulum on a clock. So you have this big grandfather clock in your living room, and here's a pendulum, and the pendulum swings upwards, comes down, and then it swings this way. So here's the pendulum on your clock. Let's say the pendulum has a length of 6 feet. That would be the radius. All right, so this is a really bad picture, so I'll label it. So here's the pendulum. And it swings, if you draw the picture, the angle that it's making, the theta, where it's going back and forth, is only equal to 0.5 radians. And I want to know, how big is the arc that this pendulum is making? Well, I would use my S theta R, my yes they are formula, and I would say I don't know that arc length the pendulum is making, but I know that my radius is, my theta, my angle is 5 radians, and I know my radius is 6 feet, and when I Multiply these together, I find out that the arc length is 3 feet. This is going 1.5 feet this way, and then 1.5 feet this way. The full arc length would be 3 feet. So I hope you remember this question from last year. Again, I've also put up the video that goes along with the author of this packet, so he'll go into a little bit more of this and a different example. So hopefully that will be enough examples and you'll, remember this. I'm going to try not to knock my pictures off the wall while I erase. And the next thing that we have to remember, which is another big thing that you did in geometry, and I do hope you remember this, and this is really looking, there we go, a little off, okay, is converting angles to radians. So an angle from degree measurement to radians, so we're going to convert from degrees to radians. And then there are times when we're going to need to convert from radians to degrees. Now guys, this, believe it or not, yesterday's lesson on the angle rotations and this lesson, this is like the foundation. These two lessons are so important. Please, please let me know if you need help. Email me right away, because if you could do these two things, you're going to be able to follow along with so many things that I do with you. Now, the most important thing we have to know, this is a definition that we have to know. 180 degrees is equal to pi radians. Now again, radians come from pieces of circles. Circles deal with pi, so they're all connected together. If I wanted to go one step further than that, 360 degrees would then be 2 pi radians, because 180 times 2 was 360. Now this, you gotta know this. So this we're gonna circle, I have stars on it. Please, please, please know this. So if I wanted to take an angle that was, say, 30 degrees, this is a very common angle. I have a 30-degree angle and I want to convert to radians. See, when we do graphs, the graphs are going to all be in radian form. So they might give you the problem with degrees, but in order to make the graph of it, you're going to have to convert. So it's very, very important that we can do this and it makes sense to us. So if I had to do this, what I would say is, okay, the angle, here's my theta, because I love this for my angle. My angle, which was 30 degrees, if I now times this by pi over 180, so this 30 degrees, and if I times it by pi over 180 degrees, what happens is I can reduce diagonally. But before I do that, before I start doing reducing and making it hard to read, let's just have this as 30 pi over 180. So I could have done this reducing diagonally, I'll do it here. Zeros reduce by 10. 3 goes into 18 6 times. So this becomes, just have enough room to write, pi over 6 radians. So my angle theta, which was 30 degrees, is now the same as pi over 6 radians. These two guys are now the same. One is in degree measure, one is in radian measure. So when I convert from degrees to radians, I am going to multiply by pi over 180. And then you're going to do a whole bunch of these for practice. Now, what if I was in radian? If I have a problem and I am in radian form, let's say I have 3 pi over 4 radians. Here's my angle now. 3 pi over 4 radians. And I want to convert this to degrees. So I'm going to convert to degrees. So what I'm going to do with my 3 pi over 4 is I'm going to multiply it by 180 over pi. So it's the complete opposite. It's the multiplicative inverse, because I'm going back and forth. Here, degrees to radians, and then radians to degrees. I flip this guy over. Now look at what happens. Here I'm actually going to reduce on the diagonal just because I think it does help somewhat. You see that the pi cancels right away. And then 4 goes into 180 45 times. So I end up with 3 times 45, 135 degrees. So one more time, 3 pi over 4 radians for my angle is the same as my angle being 135 degrees. So, good luck with the handout. Again, email me immediately if there's a problem so that I can help you as quickly as possible. Have a good day.